Okay, so I'm going to determine each product and then use a graphing calculator to verify if my product is correct. So this isn't all that different from number 2, or number 3, where we were multiplying these out, right? But this time we're also going to use a graph to verify. So I'm going to multiply the x plus 3 times negative x plus 5 times 2 minus 2x. I'm going to use a box. That's my preferred method. 2 by 2 to multiply these two out, right? So negative x squared, negative 3x, 5x, and 15. And so now when I multiply those two, that becomes negative x squared minus 3x. Oops. I want to combine these like terms. So plus 2x plus 15. So these two multiplied together become this trinomial, and then 2 minus 2x right there. Okay, but now I need, so these two became this, but I still have to multiply this, so I need to multiply these together. So I'm going to make a 3 by 2 box now, right? So that negative x squared here, the 2x, the 15, 2 minus 2x here. And now, again, multiply these two together. Multiply these two together, so that's 4x. These two, 30. These two, positive 2x to the third. These two, negative 4x squared. These two, negative 30x. And now combine my like terms, add it all together. So I'm going to start writing it in standard form. This is 2x to the third. And then these two add together, so negative 6x squared. Then these two, negative 26x, and then positive 30. Okay, so that's what it is when it's multiplied out, right? So I determined the product. But now I'm supposed to use a graphing calculator or plot points using a table of values to verify if my product's correct. So I've got this graphing calculator, right? And I want to see if x plus 3 and negative x plus 5 and 2 minus 2x is the same as this. This is a great tool for your end of course test, right? Because this allows you to check your work. It allows you to check answer choices. If you can graph and determine which two are the same, then you can determine all kinds of equivalent functions. So I'm going to graph now and see if these two turn up. And if you look, actually, it's still graphing, so they probably turned up the same. Now, it's sometimes not so easy. What if the graph is happening somewhere else? So I like to look at my table of values. Sure enough, my work is completely correct. And the table of values also gives me a good idea of my window. If you look here, notice my y values are going way up, way down to negative 40, way up to positive 90. Okay, so if I want to be able to see my whole graph, I actually need to adjust my window. So if I'm adjusting my window, I probably want to go from maybe negative 100 to 100 because I was seeing things all the way up to 90. So my x's can be fine, but my y's are the ones that are going really high. And now I can see this graph a lot better. And they're right on top of each other. So now I can plot these points. So again, to move from this graph to here, I actually prefer a table of values to get more accurate points, right? So I can see here in my table of values when x is 0, I'm at 30. So I'm going to plot that there, right? And I can see when x is 1, I'm at 0. So I'm down here already. And when x is at negative 3, I'm at 0. So I'm over here. And I can see when x is positive 3, I'm down at negative 48. 5 is 0. So now I have a general shape of the graph, right? It's going to go something like this. And I'm going to just check that I got my maximum pretty well off here. When I'm down here in the negatives, you can see it's going, yeah, negative 1 is 48. So, yeah. So it probably should have gone a little higher. Negative 1 was 48. Okay. So you do this one. And again, don't forget when you see that third, remember when you're finding the product, you need to be writing out x minus 2 times x minus 2 times x minus 2.